Okay, pre-calculus students, we are finally on page 4 of your review packet. So remember, you should be completing all of these problems before watching the videos, and just watch the videos for the parts where you get stuck. So the first problem tells us that we have an angle that's in standard position, and it passes through the point -3, 4. So we're going to just draw that point. Let's see. One, two, three, 1, 2, 3, 4. So -3, 4. And that point is on the terminal side, so we're going to draw the terminal side through that point. And we're going to draw the reference angle straight down. So here's my angle, but we use the reference angle in here to find your trig values. So I have -3 and I have 4. So you can do Pythagorean theorem, and you can find your hypotenuse here. So I'm going to switch colors, and I have the square of -3 plus the square of 4 equals c squared. And as you might have suspected, when you solve this, you're going to get 5 because it's a 3, 4, 5 triangle. So this is 5. So now it says find the 6 trig functions. So I like to line them up. SOHCAHTOA first, sine, cosine, tangent. And then I like to put the reciprocals right next to them. They're not always in that order, but it's a nice way to organize your work. Cosecant, secant, and cotangent. Okay, so the sine is the opposite over the hypotenuse. Opposite is 4, hypotenuse is 5, 4/5. Cosine is adjacent over hypotenuse, -3/5. And tangent is opposite over adjacent. So you have 4 over -3. Opposite over adjacent. 4 over -3 gives you -4/3. Cosecant is the reciprocal of the sine, so it is hypotenuse over opposite, but I know I can also just take the reciprocal of 4/5, which is 5/4. Secant is the reciprocal of -3/5, and that would be hypotenuse over adjacent, and I get -5/3. And cotangent is the reciprocal of the tangent adjacent over opposite, -3/4. In problem 16, we're finding coterminal angles. Coterminal literally means that they end in the same place. So if I had 340 degrees, 340 degrees is almost 360, goes all the way around like this. I would need another angle that would have the same terminal side. So one way to find that is to add and subtract plus or minus 360 degrees, because that will add a full circle, so you'll come around and end in the same place. So 340 plus 360, 700 degrees is coterminal. You could add 360 again and get 1060 degrees. You can keep adding 360 to get more coterminal angles, but it asks for one positive and one negative. So to find a negative angle, I'm going to subtract 360, and I get -20 degrees. -20 degrees is this little angle in here. If I start at the positive x-axis and I go clockwise, I get this little -20 degree angle here. When you're in radians, you want to add or subtract 2 pi, which is the degree measure in radians of a full circle. I have 6 pi over 4, and I can use that number if I want, but I'm going to have to end up simplifying my answers, so I'm going to start by simplifying this fraction. So 6 pi over 4 is the same as 3 pi over 2 if you divide numerator and denominator by 2. So I'm going to use 3 pi over 2 plus or minus 2 pi. If I want to get a common denominator, I have 3 pi over 2 plus 4 pi over 2 to get 7 pi over 2. And 3 pi over 2 minus 4 pi over 2 gives me negative 1 pi over 2. So I have one positive and one negative. For 17, it says to use a calculator. So let's pull up a calculator. You need to make sure you're in the right mode. So for 17a, this is a radian angle measurement, so I need to press mode and make sure I'm in radians. So I am in radians right now, so that's good. I'm going to type cosine, and the parentheses comes up right away. I need 2 pi. The pi, I need second, and then this one here, caret, that gives me 2 pi, divided by 5. And it says to round my answer to 3 decimal places, so I have let's go back to my pen, 0.309. The next one is in degrees, so I need to switch over to degrees. So mode, go down to radians, and then go over to degrees, press enter. Now I'm in degree mode, second quit, and there is no button for cotangent. So I do know that cotangent is the same as 1 over tangent. So that's what I type, 1 over tangent of 62 degrees. And I have 0.532 approximately. So it's 0.532, and I got that by typing 1 over the tangent of 62 degrees. Okay, now we have our word problems, our real world problems. Lauren is standing on the pier at the beach trying to find her sister. She spots her at the water's edge at an angle of depression of 28 degrees. If the pier is 5 yards above the sand, how far down the beach is Lauren's sister? So let's draw the situation. Here's your pier and Lauren. And here's Lauren's sister. And she spots her sister. So the angle of depression is made with the horizontal, and that was 28 degrees. Remember that the angle of depression and the angle of elevation are alternate interior angles, so they're always equal. So if you're given an angle of depression, you can always make that the angle of elevation, and then you can work inside this right triangle. So I know this is 28 degrees, I know that this one is 90 degrees, I know that the pier is 5 yards, so I know this side is 5 yards, and I need to solve over here. So I'm going to call this x. So I could set up the tangent of 28 equals 5 over x, but then I would have my x in the denominator, which I try to avoid as much as possible. So I'm going to find this angle over here, because I know all three have to add up to 180, and I subtract out the right angle, and I subtract out the 28 degrees, and I get 62 degrees. So now I can do the tangent of 62 degrees equals opposite over adjacent, and I can type that into my calculator. Let's see, I am in degree mode, so tangent 62, I get 1.88. Equals x over 5, and then I want to multiply both sides by 5, so I have x is equal to 5 times 1.88. So I get about 9.40 yards. Okay, now we have John. John is ziplining in Costa Rica from the top of a 125-foot tree to the ground, there are two lines he could take. One has an angle of depression of 35 degrees, and the other has an angle of depression of 20 degrees. And we're going to find the distance between the landing points. Okay, so I drew a quick sketch over here. I have 125 feet, and I have two lines going down. I have AB and AD, so these are his choices. And they have different angles of depression, which is going to make this picture kind of messy. So I'm going to take these triangles apart and draw them over here. But remember, what we're trying to find out is the distance between the landing points. So you could land at B, or you could land at D. So I'm trying to find this distance in here. So I'm going to find CB, and I'm going to find CD, and then I'm going to subtract those two distances to find BD. So let me draw my two triangles separately. Here's triangle ACB, and I still have 125 feet over here. And then I also want to draw triangle ACD, which also has 125 feet over here. And so I can call this one, I'll call this one little a. Little a1, and this will be little a2, because they're both opposite of angle A. I know my angle of depression is 35. Let's see if I can change. So my angle of depression is 35. That's out here. 35 degrees. But that means that I also know that down here is 35 degrees. Or more helpful, I know that this angle, angle A, is 90 minus 35, so it's 55 degrees. Over here, my angle of depression is 20 degrees, which means that this angle, angle A, is 70 degrees. So now I can do some more tangent. I can write tangent of 55 degrees is equal to my first A over 125, and for tangent 55 I get about 1.43 equals A over 125, and I multiply both sides by 125 and I get A is approximately 179 feet. Over here I have tangent of 70. Tangent of 70 is equal to my second A over 125. For a tangent of 70, I get about 2.75. Multiply both sides by 125, and I get that my second A, that was A1, this is A2, my second A is 343 feet. So this distance from C to D is 343. This distance from C to B is 179. If I subtract them, I should be able to find the distance BD. So BD equals 343 minus 179, which is about 164 feet apart. Alright, last one, we have a runner running on a circular track. And the circular track has a circumference of 60 feet. So let's draw a circle. Let's say he starts over here, because it's probably going to be like the unit circle somewhat. So he starts here and he is at 0 feet. He runs all the way around and he's at 60 feet. It says that he runs 48 feet, and I want to know the measure of the angle corresponding to this arc. So let's put some marks around the circle. If this is 0, this must be 30 over here, 30 feet. And this must be between 30 and 60, 45 feet. So he's going to run a little bit more than 45 feet. So let's see if we can use another color to show that. So he's going to go 0 to 30 to 45, a little bit more to 48 right here. So he's running a fraction of the circle. The fraction of the circle that he ran is 48 out of 60 feet. And I want to know the angle measurement for this. Well, I know that the full circle would have been 2 pi radians, so I'm trying to figure out how many radians he ran. So I can cross multiply, or I could simplify first. I'm going to start by simplifying 48 over 60. I can divide 48 by 12 and get 4, and I can divide 60 by 12 and get 5. And now I can cross multiply and my math will be a little easier. So I have 5x equals 8 pi, and divide both sides by 5. X equals 8 pi over 5. So the angle that he ran is 8 pi over 5. Okay, that is the end of your review video. Remember to make sure you understand everything in the review packet, and if you need extra practice with any of your topics, those extra practice opportunities are listed on your calendar. Good luck!